All right. Hi, good evening, everyone. This is Tiffany Woolberg, Planetarium Lecturer at the Ward Beecher Planetarium, back with our whole crew, almost all our whole crew, for another Keep Looking Up. To see, I'll introduce Elainie. This is our friend Elainie here.
Hello.
And Jenny. And Kurt.
Oh, there's the unmute. Hi. No, I'm not in the planetarium.
It's just nice to see it, though. It's nice to see Kronos. And Howard.
Hello.
And Nishan.
Hello.
And we're all here to have a great show with you guys. Our plan for this evening is we're going to start with a little star talk led by our planetarium engineer, Kurt. And then we're going to switch over and explore our solar system a little bit with Elainie. Now, a few housekeeping things before we get started. I took a quick look at the weather today, and it looks like it's going to clear up at least later tonight. It might not be clear just yet, but I really hope that our shows are encouraging you to go outside and look up. I saw in the comments of our first show 2 weeks ago that a couple of you guys had your cell phones and were listening to us, and then going outside and following along with us, and that just was so amazing. It made me really smile. I love that you guys are going out and looking and following along. The next thing I want to mention is another thing we learned from our very first episode is that there's a slight delay between our live recording and as it appears on Facebook. It was only about 10 seconds or so, but it was enough to interfere with some of the questions in our back and forth with you. We want to keep asking you questions and getting interact with you guys. So please feel free to comment, ask any questions in our comments below. Our students will relay any of those comments or questions to us, and we can answer them, but there might be a small delay, so just prepare for that. The last thing I wanted to mention is that our shows, including the first episode and this one, once we're done, will all be uploaded on our YouTube channel at Ward Beecher at YouTube. So it'll be both here on Facebook and on YouTube. All right, Kurt, are you ready to get started?
I am ready, Tiffany.
All right, take it over.
Okay, so where's my share screen? I don't have my, oh, there it is, share screen. So here we go, everybody. The software I'm using is called Stellarium, which is a free planetarium program that we have to use. It's not Kronos, it's not 3D, but it can help you see the nighttime sky. So I don't have Marvin the Martian with me here tonight, so this is Arnie the Arrow, who's going to help us find stuff around the sky. And if you look down here at the bottom, you will see, oh, it actually ran ahead on me, but that still will work. This is set for about 9:30 this evening. The reason for that is sunset is going on just now outside. 8:06 is official sunset here. But as you can tell, if you look out your window, you can't see anything out there right now because the sky is still too bright. Excuse me. It won't be until, say, 8:30 you're going to start seeing anything, and it won't be until 9:15 you're going to see everything there is to see in the nighttime sky. So we're starting just a little bit after that. And the first thing you'll notice, I do have some things here labeled in the nighttime sky. The first thing I want to point out to you is right here, when I said you'd see something by about 8:30, this is what I was referring to. It looks like an airplane that is just sitting still and not moving in the nighttime sky. And the reason it's so bright is that is the nearest planet to the Earth. That is Venus in our nighttime sky. And since Venus is the nearest planet to us and also about the same size as the Earth, it is the third brightest thing in the sky. The only two things brighter are the sun and the moon, obviously. So that is right there. But, you know, it really doesn't do me much good to tell you Venus is right here because you don't know where there is. But I can help out with these things. They are called cardinal points, and they tell you where you're looking as you go around our program. So that bright red W means west, so Venus is just a little bit north of due west at 9:30, and it's still very high in the sky. So for the next couple of weeks, we're going to get a very good show. It reached its maximum distance away from the sun a few weeks ago, so every night it is a little bit lower in the sky until eventually next month it's going to be around in the early morning sky. But for now, we can still see it in the evening. Now, my big red W will work here in our program, but it really isn't going to do you much good outside at night because you probably don't have a big red W on your western horizon. Fortunately, the nighttime sky can help you figure that out as well. We're going to come around here to the north. There's north right there. And what you want to look for is a very famous group of stars up in the sky. We have 3 bright stars that make a handle, and 4 bright stars that make a cup. And for all my planetarium veterans out there, you probably recognize that. That, of course, is the Big Dipper. And the Big Dipper is important for a couple of reasons. First off, it is bright enough that even when you're around the lights of a city, you can still see it. Second of all, the Big Dipper is always going to be up in this part of the sky someplace. And pardon the sound in the background, that is my Dowager kitty who doesn't like when I talk loud. So you saw her on camera 2 weeks ago. Now you get to hear her because she doesn't like me talking. So it's always going to be up in this part of the sky. It never sets. Okay, come here, silly. This is Merope. Say hi, Merope. Now go back down. There you go. So since it is always up in the sky and so bright, we can use the Big Dipper to find the most important star in the sky. What we're going to do is take these 2 stars at the end of the Big Dipper's cup, and we're going to draw a line from the star at the bottom of the cup to the star at the top of the cup, follow that across the sky. And the next bright star you're going to come to is right there. That star is called Polaris, which you also know better as the North Star. A lot of people think Polaris is important because it's the brightest star in the sky, but you can see there are stars all over the place that are brighter than Polaris. Matter of fact, that is the 47th brightest star in the entire sky. So what makes it important is where we find Polaris. And you see it is directly above my end. It's also directly above the North Pole of the Earth, which is the top of our planet's axis. So that means the entire sky appears to rotate around this one point, so we can then use it to find things in the nighttime sky because it's always in the same spot. So as long as you can find the Big Dipper, take those 2 stars at the end, draw a line across and find Polaris, that star will always see what direction you're looking, and that is, of course, north. So that is your marker in the nighttime sky. Now, I'm going to pull this down a little bit so we can move up here a little bit. We're going to go back and look at the Big Dipper. I'm just going to select MIG-rays here so I have something. I showed you the Big Dipper, and we're going to be talking about constellations kind of figures. The very first thing I show you in the nighttime sky isn't a constellation. The Big Dipper is part of a much larger group of stars that we call Ursa Major, which means the Great Bear in the nighttime sky. And we can put some lines up on that too. I'm looking at my notes here. Show you the Dipper is only part of the bear up here in the nighttime sky. We can also do some fancy artwork with that too. So you can see that bear a little bit better like so. I'm going to bring this around a little bit so you can see a little bit better. This is the traditional way to draw the bear in the nighttime sky. But I don't know about you, I've never seen a bear with a tail that looks like that. So why would they draw this bear with such a ridiculous tail? Well, most of our constellations come from the Greek people. But the Greek people back a long time ago used them for a lot more than just remembering where stuff was in the sky. Constellations were used to teach moral lessons to the people of the time, and probably the most important reason was they were entertainment. They didn't have TV or the internet or the Ward Beecher Planetarium for entertainment. People would go outside at night, they'd look up at the stars, they'd make up these long and involved stories about what they'd see, and they'd share it with a bunch of people. That was their entertainment. Well, it just so happens there are a bunch of stories from around the world, actually, about how both this bear and this bear, this one is actually Ursa Minor, the little bear, makes up the Little Dipper with the North Star there, how they got these long tails. Now, the story I like actually comes from several different Native American cultures who all told this same story with a few variations. But before I get to that, think about this. This bear with this ridiculous tail was seen by both people in the Mediterranean region, like Greece, and in North America across an ocean. Now, how is it that this unlikely figure was seen in both these cultures? Well, it is possible that it is possible, sorry, Merope's just being a pain tonight, that we know that Greek people didn't start the stories. They go back to the Sumerian people before them. It's possible the Sumerian people got the stories from some other place too. Maybe it goes back as far as before humans crossed the Bering Strait to inhabit North America. If that's the case, the bear could be one of the oldest creations of humans still in use today. So just food for thought there. But like I said, the story I like to tell of the bear is called The Bear in the Oak Tree Forest. And the story begins that once upon a time, there was a magic oak forest. It was magic because every night at midnight, the oak trees would get up and move around and visit with each other. I said they were entertaining. They didn't always make a lot of sense, but stick with me here. One day, a bear wandered into those woods and got lost, and she couldn't find her way out, and it was starting to get dark, so she was getting a little nervous, and the darker it became, she still couldn't find her way out, the more scared she became. Well, imagine how frightened this poor bear was at midnight when in the pitch black, all of a sudden all the trees got up and started moving around all over the place. Well, absolutely terrified, this poor bear wanted nothing more than to get out of these woods. So she began running as fast as she possibly could, not even looking where she was going, just desperately trying to get out of the woods. And because of that, she started to run into oak trees right and left. Well, as you can imagine, the oak trees didn't take too kindly to this. So they elected one tree to chase down the bear and stop her from running into all the other trees. Now, I am sure you are aware of this. But just as a general rule, bears are faster than oak trees, so the chase went on the rest of the night. Now, the trees knew that they had to get back to their original spots before the sun came up, so the sun wouldn't notice they had moved. So just as the sun was beginning to peek over the eastern horizon, there's east right there, the tree made one last desperate grab at the bear with his very longest branch, and he managed to snag the bear by her tail. Whereupon he picked up the bear by her tail, swung her around, and tossed her up into the nighttime sky where we see her today. So I guess the moral of that story is don't go around bumping into magic trees or something like that. But like I said, it's just one of a lot of stories about how that bear got up there. The Greek people had a slightly different story, but basically the bear got up into the sky the same way. The bears were grabbed by their tails, swung around, and tossed up into the sky. So there's a lot of that kind of lore that goes with it too. But we're going to come over here. Remember, we're still at 9:30. I'm going to pull back just a smidge so you can see a little bit more of the sky here. And we are looking at the spring part of the sky when we look over here in the eastern part of the sky. It's not known for its super bright stars. It does have a couple of fairly famous constellations in it, but it's not the easiest place to look for things. And really, when you're going out to look at the nighttime sky for the first time, it is kind of confusing. I like to say it's a lot like when you move to a new town for the first time. You don't know where the gas station is, the library, the grocery store. But what you do is you go out, you start looking around, you find landmarks, and you can use those landmarks to move around and find lots of other things. So after a few weeks, somebody asks you where the post office is, you can go, it's 2 blocks down, 1 block over, you know, right where it is. It's the same thing with the nighttime sky. And one of the ways that we astronomers go about finding landmarks in the sky is with something we call star hopping. And all that is really is a fancy way of saying if you know how to find something like the Big Dipper, you can then use it to move around and find lots of other things. We've already done this once. That's how we found Polaris. That is a star hop. See how simple they are? Well, as it turns out, the Big Dipper here is the best thing that you can ever learn in the nighttime sky. because there are a bunch of star hops that we can do off of the Big Dipper. It's like a key that will unlock the entire nighttime sky for you. Any time of the year you're looking at the stars, you can use the Big Dipper to find something in the nighttime sky. And at no time of the year is it easier to use than right now, because it's nearly directly overhead as you look here, looking at the nighttime sky. So I'm just going to bring this around so you can see this a little bit easier. What we're going to do next, we use these two to find the North Star off in this direction. We're going to take these two stars next, and we're going to draw a line from the top star at the top of the cup through the one at the bottom. When we do that, we're going to come down and hit this bright star right here. That star is called Regulus. And Regulus is the brightest star of the very famous and very distinct constellation of Leo the Lion in the nighttime sky. Leo looks kind of like that up there in the nighttime sky. You've probably heard that March comes in like a lion. Well, that actually comes from the nighttime sky. Leo begins rising in the east right at sunset, almost to the day of the first day of March. So in like a lion actually comes from the nighttime sky. Now, even without those lines, he's very easy to see because his head looks like a backwards question mark. Sorry, I didn't mean to move that there. It looks like a backwards question mark with Regulus as the dot on that question mark. So that's his mane, his front paws there, body runs back like that, and the tail's right there. So he's laying there in the sky. Pretty easy to spot. Not the super brightest, but even when you are around lights, the backwards question mark, what we call the sickle, is very easy to pick out in the nighttime sky. Now, we've used these two stars to find Polaris, those two to find Regulus. We can also do a star hop with the three stars we haven't used yet, the handle of the Big Dipper. Told you this thing's useful. What we're going to do is follow the curve of the handle or make an arc. When we do that, we're going to hit the fourth brightest star in the entire sky. It's called Arcturus. And what I just did there is I arced to Arcturus. We astronomers are kind of absent-minded. We need these little things to remember these star hops so we can find them in the nighttime sky. Arcturus is found in a constellation that I've always had a bit of a problem with. That's Bootes the Herdsman. Now, I don't have a problem with Bootes because it's a dumb name. As you see it spelled there, you could also call him Booties. It's one of the dumbest names in the nighttime sky. He's supposed to look something like this in the nighttime sky, but his constellation actually looks like this. And I don't know how you get a herdsman out of that. So when I see Arcturus, when I see Bootes in the nighttime sky, I usually picture something a bit more familiar. And for all of our viewers that are here in the Mahoning Valley, you'll probably see this too. There's Arcturus. That's the base of a cone right here. Here's a scoop of Handel's ice cream on that cone. And everybody remembers how big Handel's makes their ice cream cones. It used to be a double-decker cone, but the scoop has fallen off and is lying next to it over here. I think it's a little easier to see than a herdsman myself. This is a handy star hop, though, because we don't have to stop with Arcturus. If you let me get better with my cursor here. If you arc to Arcturus and then draw a straight line or make a spike, you're going to hit the other bright star of the spring sky down here. It's called Spica. And Spica is the brightest star of the very distinct and very large constellation of Virgo the Maiden. As a matter of fact, Virgo is the second largest constellation area-wise in the entire nighttime sky. She starts all the way up here behind Leo and comes all the way down past almost the horizon at 9:30. It's a huge, super long constellation. If I get rid of those lines, though, and take my little cursor off Spica, you see the stars aren't very bright except for Spica down here. And just so you get an idea, that's how the ancient Greek people saw Virgo in the nighttime sky, kind of like that. So those are some of the constellations of our spring sky that you can pick out in the nighttime sky. And there are stories about all of these things up there. Our goal, though, is not to try to make you remember every last little thing in the nighttime sky. Let me see if I can figure out how to stop share. That's it. There we go. We have at the planetarium, we have these all the time. These are called sky maps. You can use a program like Stellarium to do this, or you can get one of these. These come from a website called skymaps.com. They have PDFs on there, and it's a downloadable sky map. On one side, we have, this is the April one, so we have an almanac over here of interesting events that are going to happen in April. On the back, there are things you can see with a telescope, things you can see with your eyes, things you can see with binoculars. And over here are some commonly used astronomical terms and things like that. And then you have the circle here, which shows the nighttime sky. All you got to do to use one of these is you take the direction you're facing, and they're around, just like you were seeing there, put that direction at the bottom. So we were facing east, so east is here. I put east at the bottom, and then when I hold this up like this, what I see on the sky map is exactly what I see on the sky. Sorry, it's disappearing. That's my background doing that. But these are really handy for when you want to go out and look at the nighttime sky. So I encourage you to get one of those. And there's always something to see in the nighttime sky, including some planets in the early morning sky. So with that, I'm going to turn you back over to Tiffany, and we hope you will go out and take a look up at the stars.
All right. Hey everyone. Wonderful Star Talk. Thank you, Kurt. And I thought I saw a question. Guys, do we have any questions so far for Kurt?
Somebody asked if we have any cat constellations because they have 3 cats.
Actually, I think there is one in the southern hemisphere. I couldn't tell you the name off the top of my head. Did you hear me?
I heard you. Thank you, Kurt. Thank you for the answer to that. And if we don't have any more questions, let's see. I'm seeing a question. Okay, so Kurt, if you want to look in the comments too, or students can do that as well, and we'll absolutely address any of your comments. But we'll switch some gears now.
I'm happy to do that at the end too. So
yeah, we can also answer any questions at the end. We tried, so we're still trying to figure all this stuff out. We tried a poll on Facebook where we asked you what your favorite planet was, because Elainie is going to take us through a tour of the solar system and wants to give you an opportunity to influence where we go and when. I think what I'm going to try is I'm going to try to make a little comment and then pin the comments at the top. So if that works, find your favorite planet. Jenny, you've pinned a comment. Can you do this for us? Just type a comment that says Mercury, Venus, Earth, Mars, like that. And then folks, you guys can just like, heart, anything, react to any of those planets, and whichever one has the most interest will go to those planets first. I will be piloting, so if I'm going too fast and it makes you feel motion sick, just tell me. It's all my fault. It's not Elainie, okay? I'm using this software that I've only just started learning. It's called OpenSpace, and it's wonderful. It's free to download. You can download the software and you can play with an Xbox controller, which is so cool. So you could actually fly through space with an Xbox controller. This is a project that was funded in part by NASA, and it's meant for to visualize data, and it's just this big open platform, and we're going to use that to fly through the solar system. All right, I'm going to share my screen, and Elainie, do you want to take it over from here?
Yep, thank you, Tiffany. So as Tiffany mentioned, this is going to be a virtual tour of the solar system. So we are going to try and visit as many planets as we can based on your interest. And as Tiffany mentioned, there's a short delay. So if you could find those pinned comments and go ahead and indicate most interest, but I'm going to talk about some things that are closest to home first. So right now you're seeing the Earth. This is our home planet. Out into the system even further, water is one of the main things that we're looking for.
I think you're breaking up just a little bit, Elainie. Or where are we heading? Can you repeat? Okay, I'm not seeing Elainie. So while, you know, we're online and there's connection issues, so we're only as good as our sometimes not so great internet connection. So I'm just going to take us first to Elainie. Are you back?
Yeah, I'm here. Hello.
Hey, okay. So you broke up a little bit. I was gonna fly us to the moon. Is that where you'd like to go next?
Yes.
All right, let's go.
Here is our moon. We're getting closer to it. Seeing darkness because the moon is a very thin crescent. It's in its waning crescent phase tonight.
Okay, I'm not hearing Elainie again. I'll just take over here for a couple of minutes. Elainie, please pop in as soon as you're able.
Hi.
Hey. Are you back?
Okay, so hello.
Yeah.
Keep
Okay, so I think Elainie, if you could maybe just try to call in on your phone, that's probably going to be better. And
okay.
then for a couple minutes, I'll talk a little bit about our moon. Okay. So as Elainie mentioned, right now we have a waning crescent moon. And so we can only see a tiny sliver of the moon. But the cool thing about this software and the fact that we can like explore through space is that we can see what was called the far side of the moon. So I'm sorry to say there is no dark side of the moon, at least not consistently, because the moon goes around the Earth, and so different sides of the moon have sunlight shining on it. And right now, the moon has the sun is shining mostly on the far side of the moon. Okay, so this is the side of the moon that we never get to see from Earth. It has to do, it's kind of complicated. It has to do with gravity. It's a phrase called tidally locked, but it means that we only ever see one side of the moon. Basically, the moon is rotating at the exact same speed that it's going around the sun, around the Earth. So effectively, we only ever see one side. This is the side we don't see from Earth. You can see Earth there in the distance. Far side of the moon is pretty cool. Elainie, are you back?
I am back. Hello.
All right, wonderful. You want to take it over from here?
All right, so that was the moon. So now, Howard, can you let us know which of the pinned comments had the most interest, and that will determine which planet we visit first.
So I'm seeing the most interest for the planet Mars.
All right, let's fly to Mars. Also, as we're flying to Mars, if you guys have any questions at any point, as Tiffany mentioned, there is a delay, but please put your questions down in the comments and we'll do our best to answer them. All right, so now we are flying to Mars. Mars, also known as the red planet, because if you look at Mars, you can see it in the night sky. As Kurt mentioned, early in the morning, you can see several of the planets right now. I believe Mars is up there, and it appears red. That is because of Mars's soil. Mars is covered in iron oxide, which is just a fancy word for rust, which gives it a reddish brown color, and you can actually see that even if you look at it with your eyes in the nighttime sky. So I encourage you to go out and look at that early in the morning. Mars is the fourth planet from the sun. And even though it's red, you might think that it's hot because it's red, but it's actually very, very cold on Mars. Mars has some really interesting features. It has ice caps just like the Earth, but they are mostly frozen carbon dioxide, which just is an indicator of how cold it is there, because it has to be less than negative 100 degrees Fahrenheit for carbon dioxide to freeze. But we now know, since we've sent lots of rovers and landers to explore Mars, that there's also some water ice in those ice caps. So one of those that we've sent is the Curiosity rover, which is located in Gale Crater on Mars. And the Curiosity rover is about the size of an SUV. It studies the rocks and the geological history of Mars. And a lander that we have on Mars right now is called InSight. And InSight is trying to study the formation of Mars. And in the future, it's set to launch in July, but we'll see. Perseverance is another rover that NASA will be sending to Mars. Mars has some other really interesting features too. Mars has the largest inactive volcano in the solar system called Olympus Mons, which is over two times the height of Mount Everest. So very, very tall, and it also has some of the deepest valleys. So Valles Marineris, which is just Latin for Mariner Valley, is it is a huge canyon that is several times deeper than the Grand Canyon, and it's about as large as Canada. So some very, very interesting features on Mars. But that's all the time I have to talk about Mars. I could talk about Mars for hours. There are so many interesting things to see. But let's visit our next planet. So Howard?
I think we have a couple questions. I know you can't see us pop up.
Yeah, I cannot see you guys. I'm using my phone.
Jenny?
Someone was asking how long it took Venus to orbit the sun.
So Venus, I don't know exactly how long it takes for Venus to orbit the sun, but it is a shorter amount of time than the Earth. So a year on Venus is shorter than a year on Earth. I actually, I do know that Venus goes around the sun almost exactly 8 times in the time that it takes for the Earth to go around the sun 5 times. So that sort of gives you an idea.
5/8, yeah, that's right. It's about 225 days. So a year on Earth, a year Earth is 325. Did I get that right? 65?
365.
365. But Venus, I know that one. A year on Venus is 225 days.
All right, did we have another question?
Yes, somebody was asking if the volcanoes on Mars were ever active.
So yes, very, very early in Mars's formation, I guess, about 4.5 billion years ago, yes, Mars did have active volcanoes, but now they are extinct. Do we have any other questions before we go on to our next planet? All right, Howard, what is our next planet?
Next planet I'm seeing is Mercury.
Okay, so let's fly over to Mercury. Mercury is another rocky planet, so Mars was also one of the rocky or terrestrial planets because it has rocky terrain. It has a solid surface that you can land on. And Mercury is one of these types of planets as well. Sometimes these are also called the inner planets because they are the 4 planets that are closest to the sun. Mercury is the closest planet to the sun. It's also the smallest planet in the solar system. And as we're coming in on it, you can see that it kind of looked similar to one of the first things we looked at. That was the moon. It's covered in craters because, like the moon, Mercury does not have an atmosphere to protect it from any meteorites. So on Earth, we have an atmosphere and we see meteors or shooting stars burning up in our atmosphere because of the friction between those meteors and our atmosphere. It causes them to burn up, but Mercury doesn't have that protective atmosphere, so it's covered in craters. All right, Howard, what is our next planet?
So we have a question about Mercury. How many moons does Mercury have?
Okay, Mercury does not have any moons. The only 2 inner planets that have moons are the Earth and Mars, which I didn't mention. Like I said, there's a lot to talk about with Mars, but Mars has 2 very tiny moons called Phobos and Deimos. Do we have any other questions about Mercury before we move on? No? Okay. Howard, which planet is next?
I see a tie between Venus and Jupiter.
All right. So we will go to Venus next and then Jupiter. So Venus is the last of the 4 rocky planets. And Venus is often called the sister planet to Earth. For a lot of reasons. It's the closest to Earth, so it's a similar distance from the sun as Earth is. It's similar in size and it's similar in mass. But don't let that fool you. Venus is actually a lot different from Earth in a lot of ways too. You would think that since Venus is the closest to Earth, we would want to go there, but you hear all this talk of wanting to go to Mars instead. That's because Venus is not a place you want to be. The first mission to any planet was sent to Venus because it is the closest, and it was destroyed within a matter of minutes. That is because Venus has an extremely dense atmosphere. The atmospheric pressure on Venus is 100 times that of Earth. It's also the hottest planet because it's covered in clouds. And the clouds act like a blanket and retain all that heat, and it gets up to 930 degrees Fahrenheit on the planet Venus. So it would be very, very difficult to explore the surface of Venus. However, we are able to use satellites and certain types of imaging to look through the clouds and to learn a little bit about the surface of Venus. So we can study it from afar. We don't really want to land there. And like I mentioned, Venus is covered in clouds that reflect a lot of sunlight. So that is why, as Kurt mentioned in his star talk, Venus is the brightest object in your sky right behind the moon and the sun. So other than the sun and the moon, Venus is the brightest astronomical object that you're going to see in the sky. So now that we've talked about all of the rocky planets, we can move outward. And as Howard mentioned, Jupiter had the next most interest. So let's go to Jupiter. So Jupiter is a gas giant planet. Gas giants do not have any sort of rocky surface that we can land on. They are covered in clouds and storms. Jupiter is the most massive planet in the solar system. Jupiter is huge. And as we're coming in on it, you might see that it's very pretty. It has bands going across it. Those are just clouds and storms. And you may have heard of the Great Red Spot on Jupiter, which is just a very, very big storm. This storm has been going on for hundreds of years. It's right now it's 2 times the size of the Earth. It is huge. It is getting smaller. And in this storm, there are winds over 400 miles per hour. Jupiter has 79 confirmed moons. And to me, one of the most interesting things about Jupiter is its moons. Specifically, it has 4 bright moons called the Galilean moons. That's because they were discovered by Galileo using a telescope. So if you have a telescope, you can go out and point it at Jupiter, and you might see some little lights around it that look like maybe stars, but they're going around Jupiter. Those are the Galilean moons. And I would like to visit some of those. So one of the ones that we can visit is called Io. So let's go see Io.
All right, and while we're doing that, I just want to point out that we have some wonderful discussion in the comments right now. Venus is the hottest planet, even though it's not the closest to the sun. Elainie mentioned that because of the thick clouds that trap that heat. We were talking about asteroids. Asteroids hit all surfaces, all planets, all the moons. Our space is kind of junky. And there was another good one. So more detail it can be found in the discussion. Let's see, how many times how many Earths can you fit in Jupiter, Laura? I think is what she's asking. Like how big is Jupiter compared to Earth? Oh, I used to know that number. It's a lot.
Yeah, it's a lot. I don't remember the exact number either.
There was one other one I saw that was really great. Sorry about that. Okay, let's move on to, but head out to the comments because it was really, really great discussion going on there. I'm gonna head us to Io.
All right, so as I mentioned, Io is one of the Galilean moons. Io is a really interesting place. It's covered in active volcanoes. So there's constant volcanic activity on the surface of Io, and part of that is because Io is so close to Jupiter, and Jupiter is so big and has such strong gravity that it's just constantly pulling at Io and liquefying the material inside of it. So as you can see, it kind of looks like a potato or pizza, some people might say, and those spots that you see on it are volcanoes. Next, I want to visit my favorite moon of Jupiter, which is Europa. Again, Europa is another Galilean moon. Europa is also a very interesting place. Its crust is made up of water ice. So as we're coming in on it, you can see cracks all throughout its crust, and those are big cracks in the ice. Scientists are pretty sure that underneath that ice is a water ocean, a liquid water ocean, and the ice is sort of floating on top of it. And it's estimated that the ice is several miles thick. So Europa is a really interesting place, and it's a place that scientists have wanted to visit for a long time now to try and learn more about the water underneath its crust and see if that could potentially contain life, or at one point if it has in the past. All right, Howard, which planet are we going to go to next? We have time for one more.
We are going to visit the planet Neptune.
All right, let's go to Neptune.
Before we leave Jupiter, I want to mention that Georgia here gave us our answer. There's more than 1,300 Earths can fit inside Jupiter. That sounds right.
Wow.
Yeah, Jupiter is very big.
So as we fly in towards Neptune, you're going to see it's a very beautiful blue color. Neptune is named for the Roman god of the sea because of that color. However, we now know that it's not a sea, it's not water, but it has that color because of methane in its atmosphere. Neptune is very similar to Jupiter and all of the other gas giants in that it's covered in clouds and storms. You can see, actually, we have a very good view of the dark spot on Neptune, which is just another storm. Neptune is a very stormy place. It has the fastest winds in the solar system, up to 1,500 miles per hour. And Neptune has 14 confirmed moons of its own. All of the gas giants have lots of moons. All right, there is one more place that I want to visit in our solar system. You guys have probably already guessed what that is. It's Pluto. So let's go check out Pluto. Now, there's a lot of debate about Pluto. A question that I get asked probably more than any other question is Pluto a planet? And if it's not, why isn't it a planet? So Pluto used to be considered a planet, but in, I think it was 2006, it was reclassified as a dwarf planet or a minor planet, or sometimes we even call them Plutoids. That is because there are 3 criteria that something has to meet to be a planet. 1, it has to orbit the sun. Pluto does that. 2, it has to be massive enough that its gravity pulls it into the shape of a sphere. Pluto has that as well. But Pluto does not meet the 3rd thing, which is that the object must clear out the area of its orbit. That just means that as the object orbits the sun, it has to have strong enough gravity to pull in all the other stuff that's around it. There can't be just stray objects like asteroids and things, or else it's not massive enough to be considered a planet. So that's why Pluto is not considered a planet, because it actually lies very far in the outer reaches of the solar system in the Kuiper belt, which is similar to the asteroid belt, which lies between the inner planets and the outer planets. It's full of icy, rocky material, and actually several other minor planets that are very similar to Pluto, which we hadn't discovered before, which is why Pluto was initially considered a planet. But as you can see, as we're going around Pluto, some of it looks, so again, we're looking at, this is based on real data. So some of it looks pixelated maybe, and some of it looks a little bit clearer. That's because in 2015, the New Horizons mission, as it approached Pluto, took pictures of Pluto and then passed by it. So we only got clear pictures of one side. That's why the other side looks a little bit blurry. But before that, we didn't even know what Pluto looked like. We didn't have any nice images of Pluto. So we were very surprised when New Horizons flew by and we learned that that Pluto is actually a pretty interesting place. It has an atmosphere, and it's very, very cold because it's so far away from the sun. So there's frozen nitrogen on Pluto, as well as some water ice. And if you look at pictures of Pluto online, you can even see a cute heart-shaped feature, which everyone was pleased to find when New Horizons flew by. And that feature is actually made of snow. So Pluto is a very interesting place. And I know a lot of people would agree. So I just wanted to talk about Pluto before we wrap up. So now, before we wrap up, does anyone else have any other questions? Is there anything that anyone really wants to see? Just any last?
I will just mention a couple things in the discussion, because I know that when we post this to YouTube, that you won't have all of that. We have an astronomy professor answering lots of great questions, along with our staff. How many planets have we landed on? We've only just been on Earth. Humans have walked on the moon, and that's it so far. How long was the storm on Jupiter, the Great Red Spot? How long has that lasted? Hundreds of years. Hundreds of years. I think roughly 700 to 800 years. I think we've been monitoring it, or we've known about it as humans for 200 or 300 years.
Galileo actually discovered the storm on Jupiter.
That's right. Yes. Teresa says, my daughter wants to know if stars connect in a group or if they stay away from each other. I love that question. Elainie, do you want to answer it?
Okay, so first I want to say, check out our next show to learn all about that. So stars live in galaxies. So we live in the Milky Way galaxy, but there are billions of other galaxies out there, and they're all big groups of stars. And stars form in specific parts of the galaxy, and you can learn all about that next week.
Great. Elainie, a lot of people are begging you to go to Saturn. Can we make it just a super quick pit stop there?
Let's
all
go
right.
to Saturn.
I knew that was going to happen. It's the jewel of our solar system. It's just too pretty not to visit.
We're just going to have to do another planet show, Tiffany. That's all there is to it.
I can talk about the planets for hours. I love the planets. Okay, so this is Saturn. Again, Saturn is another gas giant. Saturn is a really, really beautiful planet. As you can see, it has big rings around it that you can even see if you look at it through a telescope. So if you find Saturn in the sky and you look at it through a telescope, you can see these rings. It's really cool to see. So the rings that go around Saturn are mostly made up of particles of dust and ice, and they're filled with asteroids and just debris that moves around Saturn. One theory as to how the rings formed is that they used to be a moon of Saturn that got broken up, or a moon that never even formed. There are a lot of different hypotheses as to why Saturn has rings. But another interesting fact about Saturn is that it's the only planet in the solar system that is less dense than water. That means if you somehow got a giant bathtub or swimming pool or something that was the size of Saturn and you put Saturn in it, it would float. It would float in water. It's the only planet that would do that. So that's pretty interesting. Saturn has the most confirmed moons out of any planet in the solar system. We're at 82 now. And that is all I have to say about Saturn. So before we wrap up, the last thing I want to do is take a look at our solar system as a whole. So we're going to start out in the center of our solar system, and we're going to fly out and show you what the solar system looks like and just do a little recap of all of our planets.
Okay, I have to find it. Oh, here we go. Okay, we're going to start with the thing in the middle of our solar system.
All right, so yes, we are approaching the sun.
Oof.
And as we move out, we can see our planets going around the sun, starting with Mercury. I may have froze. Are we flying out right now?
Yes. I was trying to figure out a way to make those, I need to move forward in time to make those trails look a little better, but we can kind of see Mercury. Then we have.
All right, so then we have Venus, and then we have Earth and Mars, and those are our 4 inner planets. And then as we travel out further, after the asteroid belt are the gas giants. So then we have Jupiter, Saturn, Uranus, and Neptune. And as you can see, all of the planets are sort of following a similar shape. I don't know if we can rotate around to show that, but the solar system is kind of flat, like a pancake. I'm not sure if we can see Pluto on here, but another reason why Pluto isn't really considered one of the major planets is because Pluto doesn't really follow those rules. Pluto's orbit is kind of tilted with respect to the rest of the solar system. So it doesn't lie on that same plane as all of the other planets. And that is our solar system. Thank you guys so much. I'm going to pass it back over to Tiffany to wrap things up.
All right, thank you, Elainie, and thank you all for, I'm going to stop sharing here. Thank you all for coming out and joining us and bearing with us through all of the the tech difficulties. Even if we did know a lot about all this stuff, that stuff kind of happens sometimes, especially with a live program. But we're still learning a lot, and I'm happy to do it and do these programs with you guys. So if you guys, Kurt and everyone, if you want to unmute your video so we can say bye. I did want to mention, again, this will be posted on YouTube and it'll be saved on our Facebook. So you can come back and check out the show or share it with others. We do plan to continue to do these weekly. And next week we have the theme of our show is galaxies. So we'll learn about different galaxy types and details like that. And one of our talks will be led by Howard here. He'll be talking a little bit about his research. So I'm really excited about that show. It'll be next week, next Saturday at 8 p.m. Eastern Daylight Savings Time, just like this one was. And I know that we have a lot of people from different parts of the world, not just from Youngstown. So I just want to remind you all that we all share the same sky. If you live real far away from Youngstown, it might look a little different, maybe a different perspective, but much of what you learned here through Kurt's talk would still be relevant, and I just hope that you guys keep looking up with us. Thank you all. Have a wonderful evening.